Okay, so today we're going to look at best method to solve a quadratic. In fact, I don't know, it might be better to say methods to solve a quadratic, because the best method kind of depends on the problem, because they're not all, you can't use all the methods all the time, and so you have to be careful about when to do which one when we leave it open-ended. And so just to kind of give you the final story first, today's worksheet is going to be solved using whatever method you want. And so we need to quickly revisit each of these methods and make sure we understand them and we understand when we can use them. So let's just start at the top left, and we'll just work our way around. The square root method. I guess the main thing with the square root method is don't forget the plus or minus when you put the square roots on. Let's see. So I overheard you say the square root method is the easiest method. I would agree with that, except you can't always use it. So when can you use it? When can you use it? When b equals 0. So easy method, but only when b equals 0. And again, we're talking about ax squared plus bx plus c equals 0. I don't know that there's really you need to write what the method is, but solve for x squared, and then plus or minus square root on both sides, and you're done. We like that. How about 1/2 x squared minus 18 equals 0? There was one kind of like that on the test that some people messed up. So what do you want to do first on that problem? Add 18. 1/2 x squared equals 18. What do you want to do next? Wait, let's divide by a half first. Let's don't square root first. If you square root first, you can, but then you got to square root 1/2, and that's not going to, it's doable, it's just not going to be fun. So how do I divide by 1/2? Multiply by 2. Maybe we should have just said that from the get-go. To fix the 1/2, we can multiply by 2. So x squared equals 36. So plus or minus 6. So square root method. Great method, super easy method. Just be careful because you can't always use it. All right, factoring. How would you describe factoring? Easy, medium, hard? Medium or depends? I think that's fair. Medium or depends. Because if a is equal to 1, I'd say easy. If a is not equal to 1, then who knows? It could be medium, it could be crazy. Like anywhere medium to super yucky. And I guess we should say this as well, it also is not always possible. Yeah, if A has a ton of factors, or if C has a ton of factors, then it's a yucky method, because you got to grind through all the different possibilities and figure out what works. So, yeah, so I guess we should do a couple of easy examples here. Here's one that people like to miss. 6x squared minus 3x equals 0. How would you like to reduce? Divide by 3. 2x squared minus x equals 0. Like that. What would you like to do next? How are we going to factor that? Take out an x. This was also on the test. Take out an x. 2x minus 1 equals 0. So set both of them equal to 0. I think on the test it was 8x squared minus 24x, or plus 24x, something like that. So x equals 0, or x equals 1/2. That's not the usual factoring type of problem we do, but that's, so what would that be? If c equals 0, that's an easy one, because then you GCF it. But people forget about that, and they try to do something else. They try to factor strangely. Let's do one more where it's an easy example. So x squared minus 4x minus 12 equals 0. So that's sort of what you think of the normal factoring type problem, and an easy normal factoring type problem. X minus 6 and x plus 2 equals 0. So x equals 6 and x equals negative 2. So factoring is kind of in the middle. Sometimes it's easy, sometimes it's yucky. It doesn't always work. All right, completing the square. I would agree. Worst one. Worst. What else to say about that? It is the worst. I guess as a trade-off for being the worst, or something positive you could say about the method, it does always work. And remember, this was also on the test. Again, like today's notes is like we've done all of this before, but we did them like one thing at a time. Now we're kind of zooming out, looking at all the methods, trying to make sure we understand all of them. What am I about to write here? If you want it to work, you got to make something happen before you can use the method. Well, you sort of force it into a perfect square, but you can't do that until
you have to make ax squared plus b.
You do want it in ax squared plus bx, move the c out of the way, but you got to have a equals 1. And when you do that, that's when sometimes things get really ugly. Let's see, do we want to do one of these? You're like, no, not really. 2x squared plus 8x, I'll make one that works. Plus, what should we do? I want to make it big, but not too big. Plus 40. So I'm making this up, so who knows what we're going to get for an answer. But it's like one of the background teacher type things. Completing the square always works, so it's easy to make one up. You know you're going to get an answer. When you're making up factoring problems and square root problems, you've got to be a little more careful. All right, what do you want to do first on completing the square on this one? Divide by 2. I would have also accepted move the 40 over. X squared plus 4x. Oh, dare I get brave here and divide by 2 and move c over?
That's easy.
I mean, easy, yes, but be careful. What's the next step, or the next 3 steps?
Take out b divided by 2 squared, and then I forgot which one you do.
Half it, square it, add it. So you're right. Take half of b. That's 2. Square it, you get 4. And then we'll add it to both sides. Half of b, square it, add it to both sides. We created a perfect square. We just completed the square when we added the 4. So x plus 2 squared equals negative 16. Oh, that's convenient. Because then I square root that. I would say I get not exactly 4i. That's not quite right.
Negative 2 plus or minus 4.
The plus or minus on there. So when you square root both sides, don't forget the plus or minus. And then move the 2 over, so negative 2 plus or minus 4i. Worst method? I don't know, maybe. But always works. still sticking with worst. Fair enough. Quadratic formula. X equals negative b plus or minus the square root of b squared minus 4ac all over 2a. What about when does it work? Always works. And so I think because quadratic formula and complete the square always work, most students are like, I'd rather use the quadratic formula, therefore I never need to use complete the square. That is a true statement. Except when I tell you, solve this by completing the square. Because we'll do some things later that require us to complete the square. So we'll keep forcing you into that method, even though on your own you would probably pick the quadratic formula. We're still in the process of memorizing that, so let's write it down one more time. And I wonder if, let's solve the same problem we just did. With a different method. Obviously we should get the same answers, but let's just confirm. And then we'll also learn if we really do think this is the easier method. I think it is, but we'll see. So forget what we just did, even though we already know the answer. We're going to get there a different way. What would you like to do first on this one? We can still divide by 2. Make our life easier. X squared plus 4x plus 20 equals 0. So then we sing the song. X equals negative b plus or minus the square root b squared minus 4ac all over 2a. Okay, 16 minus 80. Hey, remember what the b squared minus 4ac is called? Just a little review here. Discriminant. And what does it tell us? Yeah, the type of solutions we get. Negative 4 plus or minus the square root of 16 minus 80. That's going to be negative 64 all over 2. Negative 4 plus or minus 8i all over 2. And what do you know? We got the same thing as we did when we used the completing the square method. Go figure. And it was probably faster. Less thinking, maybe. I guess I don't know. It's hard to make the case to use complete the square. People are going to use quadratic formula. When you get a weird one that you can't figure out, go to quadratic formula. That's the simple way to say it. Like, which method should I use? Well, if there's no b term, then square roots. If you can like just spot the factors, then factor it. If you can't factor it, then you go to the quadratic formula. So here's my summary of this page. If b equals 0, square roots. If factor is easy, then factoring. Right? Because if factor is hard and you can't figure out the factors, then go to the quadratic formula. All others, quadratic formula. Which, yes, means completing the square gets left out in the cold.
So if A is already 1, we should factor.
Maybe, but maybe it doesn't factor. Right? Let's look at some. So let's turn to the next page is the assignment for today. Well, number 6 has the same issue as number 1. So I'm circling number 1. So A is 1, so I'm thinking factoring. Yeah. But I'm trying to think of numbers that multiply to 11 and add to 3. No. So B is not equal to 0. I can't use the square root method. I don't think of any factors that work. So quadratic formula or complete the square. Yeah, I know. Quadratic formula, that's fine. x equals negative b plus or minus the square root b squared minus 4ac all over 2a. (44 minus 9). 35, but negative 35. And by the way, your answers will confirm if you could have factored. 3 plus or minus I root 35 all over 2. So yeah, pretty sure I wasn't going to be factoring that, because those are my factors. Those would be my factors. If I was amazing and I could factor it, those would be my factors. How about number 2? You want to use the quadratic formula? I think it factors though.
Oh yeah. 2 and 1.
2 times 2 gives me 4. I want that to be positive and the minus 1. There's a few people who are still messing up this when they factor this. They're doing the shortcut and they're like, oh look, x equals negative 2. Yes. And then x equals positive 1. Like, no, because when you show that middle step, you realize that x equals 1/2. Okay, that's a reason I did that one is if you couldn't figure out the factors for that one, you would use the quadratic formula, and what answers would you get? You get those answers, so it's okay. It just says, and the directions say any algebraic method. I guess it says algebraic because we don't want you like graphing it and picking the numbers off the graph. Your favorite method is copy off your neighbor method. That's another method that works. I circled number 4, but I don't know that we need to do number 4 because what method would you use for number 4? Let's phrase it that way. You'd have to use either the quadratic formula or complete the square. It wouldn't be a hard complete the square. And we are doing the odds, so you don't need to do that one at all. How about number 5? That's the square root method. How do you know we're going to use the square root method on this one? There is no b, or b equals 0. And just as like a note to myself, plus or minus square root method. So let's add 2 to both sides. Again, there was one like this on the test that some people messed up. What would you want to do next? I would multiply by negative 3, which is the same thing as dividing by negative 1/3. So x squared equals negative 36. So plus or minus 6i. Okay, so your assignment is the odds. I think that's 9 problems. Again, any method you like. And, I mean, yes, that means you could use the quadratic formula on all of them. I just feel like that would take longer. Like, take a minute to see if there's no b. Take a minute to see if it factors. And if those don't work, then go to the quadratic formula. I will pass the test back now. So you can work on that, but I'll pass the test back and we can take a look at those.